Hello! We come to you today from the Laketran Park and Ride in Wickliffe, Ohio, just east of downtown Cleveland, and a stop on the American Solar Energy National Solar Tour. As you know, mass transit is the most efficient way to move people around other than walking or bicycling, and something that we're going to show you today makes that even more the case.
Welcome back to E-Hermes, your electric adventure travel channel. Please remember to subscribe, hit the like button, and hit that bell button to be notified of our upcoming content.
Take a look at these two buses behind me here at the Park and Ride stop. You will see the towers hanging over them, and they are being charged as they do their normal stop for a layover. They charge for about 6 to 10 minutes, and then they're back on the road. All electric buses, and we'll hear some more about that from some of the people involved.
We were given tours of the buses, but I chose to stay outside and focus on the electrical components rather than the interior of the bus, which is pretty much like any other bus.
So how long does it take to charge this, and how long is it good for?
So the amount of time it takes to charge varies. It depends on the weather and traffic and all those other things. It should take between 6 and 10 minutes.
Oh wow!
And how long is that good for then? How long is its route before it has to be back here?
So it has enough batteries to run almost the whole day without charging. They are designed to charge once an hour. So in theory, the bus can run on this route forever. Buses use about 40 to 50% of the energy that's electrically provided to them for HVAC and like auxiliary functions. So, you know, a bus still has air brakes like a commercial vehicle from 100 years ago, but has an electric air compressor that provides the air to it. You know, everything else, just like an electric car, has to be provided with different forms of electrical energy. So, a lot of what a bus needs is air conditioning and heating. You know, it's a big area, the doors open all the time, so we use a huge amount of energy just to keep the bus the same temperature. So, when it's a day like this, you know, it's not as bad. Heat is much more energy intensive than air conditioning is, so there can be pretty significant variations in how much energy the bus needs to get to the next charger.
Does it do regenerative braking at all?
Yes.
Okay.
The only way that can be turned off is there's a secret switch that we don't tell people about that can be turned off. It does have intelligent traction control, so if you're braking and you start to lose traction, the computer will disable the regenerative braking. But other than that, it's on all the time.
Where are the batteries stored?
There are several battery packs. There's some on the roof, and then in buses, normally there is a fuel tank just ahead of the rear wheels. So there's also a battery pack there, which would be normally where the diesel tank is.
Well, the end of the bus, you're on a lower level, which I think a lot of people like.
Yeah.
But then you step up to the back level because of the fuel tanks.
In a normal bus, that's designed that way because there's the differential for the axle is there, and then you have the transmission and the engine. So they didn't redesign the back of the bus for the electrical parts, so there's still the electric motor, there's still a traditional axle with differential, and so they basically just put a battery where the fuel tank would go. Everything else is on the roof. Our average speed is 24 miles an hour.
Yeah, I got a quick question.
Sure.
Will this ever replace the Park and Ride going downtown?
So they sell that same bus, so they're different types of buses. The one that we use for the Park and Ride, they do now have a battery version of that. Okay. We replaced ours in 2016 and 18. They did not have a version of it at that time. It does not have the capability to charge like this. It's still a plug-in type. Okay. The only buses that charge like this are this kind of style.
Could this one make it downtown and back?
Yeah, we've taken these downtown and back. We've taken them to show to Cleveland. This bus has about an 80 to 100 mile range between charges. So it has a decent amount of range without being charged. We charge it, the system was built so that if a charger at one end was out of service, the bus could still provide its service every day. So the chargers are a little redundant. They do help us keep the battery voltage or battery state of charge at the right point longer. So instead of taking big dips by charging every lap, we can keep it, close to that sweet spot all day, which is our goal for battery life.
So what happens when there's 2 feet of snow on top of that bus?
The arm that comes down has some heating components to it, and the rails on the top of the bus also have heating parts to them, so they will melt the snow off of it. We store the buses inside, so when it leaves the garage, even if it's super snowy, it's only the amount of snow that collects on it that day, and since you're moving and you're already a little warm, we don't have a lot of issues with snow gathering on the top of the bus. It can happen, but we haven't had any problems. Buses, you can buy this same exact vehicle with different battery configurations and sort of end uses. So you can buy this bus with more batteries on it than we bought if you want to charge it in the garage overnight. Obviously, more batteries equals more money, so we did a lot of sort of calculations and math and everything to figure out what the right battery size was. So this bus has around 235 kilowatts of battery storage on it. It's not a whole lot, but because we can charge it every hour, we don't need a whole lot. One of the things when we selected this manufacturer, one of the things that was important to us is this: we can service this in our own shop. We don't have to send it away for someone else to work on it. And these batteries have individually replaceable cells. So unlike a lot of EVs where you're taking out a whole battery pack and putting a whole new one, that's not how this works. We can take out very small components of battery. So if we run some diagnostics and it says this little piece of cell failed, we just take that out and put in a new one. It's a little more complicated than that, but it's also not that much more complicated than that. And so there's not the problem.
So you do your own in-house maintenance,
Yep.
is what you're saying?
Yep.
You don't send it out for...
Nope.
That's important.
Nope.
That's in the long run.
It's important to us because it's cheaper, we can control the process, and being able to replace one part of a battery, it's not, most batteries, the whole cell system doesn't fail at the same time. A little piece of it fails, so we can take that out and put it in the new. So that, for us, was important because it'll reduce long-term maintenance costs. There's a system that's sold by Cummins that only they can work on it, and they have to replace the whole battery. So we did not take that one.
Can you talk a little bit about the maintenance savings on this from a diesel bus, which your typical buses are?
Yeah, so when we think about costs in the transit world, we think of it by cost per 100 miles, which includes fuel and maintenance and all the things together that go into that. So we just ran the calculations recently. I gotta remember them. It is, I believe, a diesel bus was around $65 per 100 miles, and an electric bus was like 47, I think. So it's quite a bit cheaper than a diesel bus. And right now fuel has gone, we all see it gone crazy. We do a thing where we hedge our fuel, so we buy it and it's more than $250. Even at $2.50 a gallon in diesel, this bus is significantly cheaper. There's some other things people don't think about when they interact with a bus. Normally if we were standing here, you hear a diesel bus, it'd be hard to hear. And that, people think about pollution in terms of smoke and air and all those things. They don't necessarily think about it as noise. And in our business, when you have 5 of these sitting together, you're trying to have a conversation. It can be very difficult. So one of the really big benefits that I think people didn't expect is how quiet they are when you're standing next to them. And when you're riding, have you ever ridden a bus like this?
Oh yeah.
It's louder. With these, you just kind of hear that hum. You can have a much more pleasant conversation with the other folks on the bus riding. Or in places like downtown Willoughby, where the buildings are close together, this doesn't bounce sound off all the buildings; it just kind of goes right through. So if you're outside eating at Sugar River Diner, you don't have to hear it.
Our drivers appreciate it too. That's their office for 8 hours a day, and it just got a lot quieter and more peaceful.
We then had a brief Q&A where I discussed some of the features of the F-150 Lightning.
This is a 130 kilowatt hour battery in here. I was surprised the bus was only 200 something. This truck does weigh about 8,000 pounds, which is about 2,500 pounds more than a gas powered one. And to someone's question about the road taxes, not only do we not pay road tax, we actually put more wear on the roads. That's something you're gonna have to discuss because it's heavier. I mean, it's heavier. There is an onboard charger. This, in fact, this is not DC charging. This is AC charging. That's not a charger, even though people call them that. The charger is on board. When you go to Electrify America, that is a DC charger. It's these bottom pins here. This is where the DC charging occurs. This is a CCS charger. This is J1772, and then this is what makes it CCS.
A few of us then got a tour behind the wizard's curtain.
There's There's 3 cabinets per charger. Each cabinet is 125 kilowatts, basically. So you can build these systems. These are all modular, so we could build one with fewer cabinets or with more cabinets. It's up to us. The most they do is 4. So you can do up to 600 kilowatts. These put about 800 amps into the bus when it's charging. So there's a significant amount of energy going through these to the bus.
So, yeah, that's probably pretty dangerous stuff in there.
No,
so
there's no
what's
bus charging, so it's...
what's the incoming power?
This building has a standard 600 amp or 1600 amp
4827480.
480,
Yeah, 3-phase.
So one of the things we did when we designed everything was we built it with off-the-shelf, if you will, utilities components. So all the stuff in here from the First Energy perspective is standard stuff they have in a warehouse. So we didn't want a bunch of custom electrical stuff that was going to be expensive and long lead time, and if it failed, what do you do? So, you know, the transformer outside here is one that they've got 20 in a warehouse somewhere. If we need a new one, they just come and put it down. So that's the nice part about what we did is it's all standard utility stuff and it's spread out. So if we have a power failure, you know, probably not going to have a power failure in Mentor and Wycliffe and in Painesville all at the same time. So we have a lot of redundancy built into what we did, and so far it's served us well. You know, we've had power outages here and in other places, but it's been isolated, so the buses can keep running. So, yeah. But this building was built with electric charging in mind, so over half of this building is dedicated just to electrical infrastructure versus the passenger part. So
I see the extra cooling up there because they generate quite a bit of heat.
Yeah, the mechanical engineers were kind of like, you need what now? When we were designing
this little room,
it was crazy. And really, this room is too small. You know, one of the things we learned in this building is this just isn't enough room. There's to put these in and out of here. It's our electrical contractor developed a very interesting system, but this actually has to come out. So it's not especially fun here. Over at Lakeland, where we have the same setup, it's a lot better. But we were the first ones to put these indoors. ABB, you know, designed the system to be outside. And we said, look, we're Northeast Ohio. You know, we don't really want this kind of expensive equipment sitting outside. You know, this system with the charging head is about $750,000 per system, not installed. So by the time you get to the installation cost, it's really expensive. So we said in Northeast Ohio, with all the salt spray on the highway and everything, you know, these are just air ventilation. We didn't really want salt spray being sucked in this and blown out the top, so we put it all inside. In Painesville, they are outside, but they're kind of protected by a building a little bit, so it's not as bad. We're also the first ones, you know, outside we have the pantographs in the poles. We stopped by Lakeland Community College, they're in the roof of the building. We were also the first ones to do that in the U.S., or at all with ABB. We worked with their engineering department to kind of design the bracketry that's in the building. So right now they're not anywhere else like that. So there again, that building was built with it. Originally it's all fully integrated into the building. It was designed like that from the ground up. So it's pretty cool.
Amps coming into this?
So there's the First Energy system is a standard 440, and it's a 1600 amp transformer. So these can output it varies. So the bus calls for different amounts of charge as it goes. These will vary how much they can put into a bus. I think their max, 3-unit setup is 800 amps. Yeah, so in our garage, we do have one slow charger, which in our case is just one of these cabinets. So everything is kind of modular. So if anything goes bad, you just kind of take one out, put a new one in. One of these cabinets can charge up to 3 buses at a time, slow charge. So in our garage, we have 3 kind of whips that come down and the buses can charge. It takes roughly 4 hours. It doesn't actually charge all 4 of them at the same time. It charges each one of them up to a certain amount. So it'll take every bus to 80%, or up to like 40%. Then it'll go around and get them all to 60%. Then it'll go around and get them all to 80%. So it kind of does that all on its own. So we do some charging overnight, but our system was engineered and designed to be all on the road. So we only have 3 chargers in the building. So we can't charge all 10 of our buses overnight, even if we wanted to.
You talked about keeping that in the middle of the battery pack. So what do you charge? 20 to 80, something like that?
We try to stay between 60 and 80.
60 maybe, okay.
Doesn't always work out that way, but that's where we try to put the batteries in their kind of normal life.
Mm-hmm.
So, and if everything's working the way it's supposed to, it generally does stay there. Sometimes traffic and weather get the best of us. You know, especially in rush hour, sometimes the bus doesn't have as much time to charge as we would like. But you know, to us, service is more important than that. So they, you know, the drivers will do a little bit less charging than they might want to, and they'll stay on time. So there's a lot of variability in it, though. But so far, you know, we've been running them for a year now and really haven't had any major issues. There was obviously some, you know, drivers had to get used to it.
Sure.
They had to understand the importance of it. But now that they've kind of, everybody's broken in, everything works pretty well.
I bet the drivers love it.
It's one of those things at first they didn't.
Sure.
They're like, I don't want to have to connect to this thing, and you know, this is harder than normal, and you know, I don't know how to do it, and all that kind of stuff, and because it's changed.
Sure.
You know, I have a CDL, I drive a bus just like anybody else, and I remember I was like, you know, I want to know why this is so hard. So I had our training department. I was like, take me out, show me, train me as if I'm a driver. And you know, I pulled up and got the pantograph to come down on my first try without a lot of issues. So then I could walk around and tell the drivers, like, this is not that hard. You know, you pull up like you should for a customer to step off the bus easily. You kneel the bus, you push one button. It's not that bad. But they're used to it now. Now that they have it, they like it a lot because it's so quiet. Some of them, you know, we have them derated, so when you floor it, it doesn't run full throttle. It kind of, you know, eases you into it. Some of them would like us to turn that up a little so that it's more like a Tesla.
A sports bus.
Yeah. Buses aren't speedy, you know. We like to lumber along. But now, you know, everybody's used to it, and it's not a big deal.
As you can see, there are all kinds of exciting and innovative new solutions out there for electrical transportation. We hope you enjoyed this video about the electric bus system in Lake County, Ohio. If you did, please hit the like button, please subscribe, and please hit that bell button to be notified of our upcoming content. Thank you.